Well, delighted to see you all here, ladies and gentlemen. The topic today is innovations in medicine. We're looking for an interesting panel discussion on the medical challenges and trends in technology innovation for the next 20 years. And I'm delighted to be joined by four distinguished guests from the local environment. So we have, first of all, Jeremy Latham, who's a hip arthroplasty surgeon based here in Southampton, specialising in all aspects of primary and revision surgery. He was an early and enthusiastic adopter of hip resurfacing and metal-on-metal hip replacement. He went on to set up the Metal Hips Research Group and Southampton Orthopaedics, which is a centre for arthroplasty and revision surgery, to bring together clinicians, scientists and engineers who have an interest in the mysteries of joint replacement surgery. Next to him is Tim Elliott, who's a Professor of Experimental Oncology here at the University of Southampton, where he's the Director of Southampton Centre for Cancer Immunology, and he'll soon be the proud possessor of a fantastic new building, which will be opening in about a year from now. He's the Deputy Director of Interdisciplinary Southampton Institute for Life Sciences and currently Interim Pro-Vice-Chancellor of Research. He's a molecular immunologist with over 130 publications in the subject and has incorporated discoveries in the areas of antigen processing, T-cell regulation and the immunodominance into the development of new cancer therapies. Next to him is our guest here from industry. This is Dr. David Moser, who's Head of Research for the Blatchford Group, a leading provider of prosthetics headquartered in Basingstoke. He's also a visiting academic at the University of Southampton, so he has a very local interest. He's been at the forefront of many leading innovations in the field of prosthetics, developing the first hydraulic and microprocessor controlled ankles, and more recently won the prestigious Roberts Award for Engineering Innovation from the Royal Academy of Engineering for the Lynx microprocessor knee ankle prosthesis. Very good indeed. And finally, but not last, least rather, Bill Gillespie, who's the Chief Executive of the Wessex Academic Health Science Network, who's been there since the beginning of January of this year. He's almost 30 years' experience in health service management, including Chief Executive positions in primary care trusts in Kent and London, and 2 years leading the development of primary care strategy for the Gulf State of Qatar. So we have a very distinguished panel, I think, who are going to give us some great insights into what's going to happen over the next 20 years. And obviously the key here is that after they've given us their first thoughts, we're looking for interesting questions from you, the audience, for good participation. So first of all, ask Jeremy to give his views.
Thank you very much, David, and thank you to all of you for staying for this afternoon's session. And many thanks to Peter Smith from Fortisnet for inviting me to talk, and of course Peter Burkett and his team for making this such a riotous success so far. But I feel very overwhelmed by my illustrious colleagues here. I'm just a jobbing orthopaedic surgeon who got himself into a bit of trouble a few years ago and dug his way out of it. So I just want to give you my thoughts about what I think is going to happen in the next 20 years in my field of joint replacement surgery. Of course, in 20 years' time, I'm hoping this will be my lifestyle. I suspect, and some of my colleagues say more like that. I hope not. So this is what we're all here today, to try and avoid all this sort of dreadfulness at the end of people's lives and how we can use technology to keep us all out of these sorts of places for longer. Orthopaedic surgery is a curious mix of technology and the art of medicine. The chap on the far, well, in the middle of that picture, there's a stamp and then the chap holding the camera, is Sir John Charnley. He was the pioneer of modern joint replacement surgery. He was an engineer by training, who then became an orthopaedic surgeon. And he was around at a very interesting time of rapid changes in technology. After the war, wars of course bring forward huge technological advancements. The advent of new plastics, safe anaesthesia, and safe processes for delivering care, all rapidly transformed in the 1950s, and particularly the rise of antibiotics, the use of antibiotics. He was uniquely positioned to use those changes in technology to develop the modern hip replacement. And it was the 60th anniversary of the modern hip replacement a couple of years ago, and it was commemorated with a stamp. And I would say that modern hip replacement surgery is right up there in terms of global, life-changing technology. It's made huge differences to millions and millions of people, much in the same way as the contraceptive pill freed up women to control their infertility, and the jumbo jet to allow rapid, safe, fast transport across the world. So it's right up there with those massive technological innovations of the 20th century. But we face huge challenges, not least of which is the ageing population. If you look at the demographics of people over the age of 60 to 70, it's going to massively increase over the next few years. And we've got to have the healthcare services to deal with that explosion in old people who are going to be living with chronic diseases for longer. We're dealing with patients who have hip replacements at a younger age, who may well be obese and have difficult congenital abnormalities to deal with, but also we're going to be dealing with an ageing population who may well have other diseases such as diabetes, cancer, respiratory diseases, all of which affect the outcome of the surgery that we do. The particular problem is in the news today as well, because the United Nations are going to collaborate to try and overcome this, is the problem of organism resistance to infection. So organisms acquiring resistance to the antibiotics we have now, and we have nothing left in our arsenal of drugs. So there's a huge impetus to develop new antibiotic drugs to overcome the problems of resistance, which could wipe out millions and millions of people and prevent surgeons like me from doing safe joint replacement surgery. If we can't use antibiotics, we can't put implants in people with the technology we have now. And that's a big problem. So technology really we should use to make our lives simpler, easier, safer, and hopefully cheaper. How can we use technology to do that? Well, from my point of view, we can use smart technology to improve the way we put implants into people. We can understand how the geometry of a hip and hip replacement affects the reconstruction of the hip that we do, hopefully to give it better function and hopefully to make it last longer. We can use different materials. We can modify materials. Vitali Gorianov, a colleague of mine, has done his PhD on modifying the surface of titanium using electron beams. At the nano level, he can modify the surface of titanium to make bone cells stick to it. So we can make the materials more biocompatible using technology. We can get people out of hospital quicker by treating them better. That has huge implications in terms of healthcare spend. And also I'll talk a bit about monitoring. How do we monitor our joint replacements so that patients don't have to come back and see me every year or so? Can we use smart technology to monitor what's going on in our bodies and alert that patient to a problem arising? And it's very interesting to see that sort of technology emerging in environments like this. There's a very good stand out in the exhibition centre. I invite you to see it. Somebody mentioned the Fraunhofer Institute earlier. This is a femoral stem, a component for a hip replacement, which one could use to put little processes inside that stem. You could put a load cell, a lab on a chip, so it could respond to its environment, both mechanically and biochemically, and perhaps manufacture a drug to prevent a fracture from forming under adverse loading conditions, or monitor that patient's hip replacement and say, this hip replacement is failing, you need to go and see your doctor. So there's that possibility emerging with new materials. We're using different ways of manufacturing implants. Commonly, orthopaedic implants are made by forging and casting. We're now using much more in the way of 3D printing. This cup here, which we put into the socket of the hip, is made by 3D printing. We can do custom-made implants for big bony defects or the treatment of tumours. We're using different bearing materials. If you look at the Aurora stand up there, they're using very interesting materials to use in hip replacement surgery. Navigation and robotics have transformed the way we put these implants into people so we can reliably and consistently do the operations well. And of course, meetings like this improve our collaborative attempts. So engineers and orthopaedic surgeons working closer and closer together so we don't make mistakes, so we develop better implants and better outcomes. Can we have the first video, please? I mentioned 3D printing. Actually no sound, the sound doesn't help really. This is a way of making these cups, these acetabular cups for the hip replacement, using an Arcan machine. This is additive technology. So titanium is heated up and electron beams, layer by layer, create a socket for me to use in a hip replacement. If we did this 500 years ago, we'd be burnt at the stake. It's just incredible. It is really like witchcraft. So layer by layer, a component is made in a very, very well-controlled manner, which allows us to use that to reconstruct the hip joint. Really clever stuff. Okay, next slide, please. And how do we tailor our implants and surgery better? How do we use the technology we have now to make the treatment better? I could do 100 hip replacements in people of the same age and gender, yet the outcomes may be subtly different. We know there are a host factors which determine outcome. It's very interesting to see the genomic project out there and how that's going to help us develop personalised treatment for our patients. We're using nanotechnology perhaps to deliver drugs in a controlled way and understanding the effects of nanoparticles in our bodies. It's a very good nano group at Southampton. We're using clever coatings of implants, such as silver. Silver repels bacteria. So we're using this multidisciplinary approach to resolving the problem of infection. We can have different compounds to help lubricate joints, perhaps delaying the need for surgery by using smart compounds to keep a joint working for longer. And of course the use of stem cells, which Vitaly will talk to us about a bit later. But the problem with revolutions in the field of work that I do is they sometimes go badly wrong. And I think we can learn lessons from the automotive industry. It was the 50th anniversary of the Porsche 911 a few years ago. And that the genetics or the DNA of that car are absolutely the same all the way through that line, from the earliest one in the 1960s to the current iteration. And Porsche have been successful because A, they've got a great product, but they haven't tinkered with it too much. Each change they've done has been incremental and improving. They haven't reinvented the wheel with all the risks that entails. There's a lesson there for us in orthopaedic surgery. I'll come on to that in a minute. It was very interesting using in the paper yesterday, using technology, which I'll use to wrap up this talk, but Microsoft now say they're going to solve the problem of cancer in 10 years using technology, artificial intelligence and machine learning to analyse genomic sequences to see where they've gone wrong and to use that as a targeted treatment for cancers. So if anybody could do it, I suppose Bill Gates and the trillions of dollars that he has perhaps could. But it does go wrong sometimes in our world, and change introduces new modes of failure. The systems we're involved with are complex, and complex systems by necessity are hazardous. And in my world, catastrophe is always just around the corner. If I don't get it right, things go badly wrong for that patient, for which I'm responsible. And as I said, change introduces new modes of failure. And we have to understand that when we're introducing new technology into our world. So I'm going to have the video for that, please. And this is just a short sort of horror video, which might put you off your lunch if you haven't had it yet. But these are metal hips which have gone wrong. David said I was an early and enthusiastic adopter of metal hips, and I wish I'd never met them because some of them have gone horribly wrong. Not all of them, but some of them have. And we've been faced with very difficult reconstruction problems, sorting out the consequences of a host reaction to the debris that emerges from some of these hip replacements. This is dead bone, basically. And here's a reaction to a metal hip. Lots of fluid and bush. Horribleness. Well, we'll move swiftly on from that, I think. Last slide, please. There's one more to go, I think. Yeah, here we go. Next one. So just to conclude, new technology is wonderful, but it does bring with it a degree of risk and unexpected modes of failure, which is very pertinent in my world. Evolution rather than revolution has served us well in orthopaedics for many, many years. And I think we can do better if we collaborate better. And this is what this meeting is all about today. Bringing us all together to see where we can be synergistic in our approaches to healthcare. And I think, really, in the future, will we do things much differently? I don't think the delivery of healthcare will be much different, but perhaps the way we do it will be. Thank you very much.
Thank you, Jeremy. I think now I'll pass on to Tim, who will give us his view of the next 20 years.
Thanks. So I'll be very brief. I think it's more important that we engage in a discussion rather than we tell you how cancer immunology is going to develop over the next 20 years. We haven't conferred before, and yet I guess we all come to the same conclusion that over the next 20 years, it's going to be population demographics that will dominate our thinking around medical care and technology that might impinge on it. So, in 20 years' time, we're going to be faced with an expanded population of the over 60s. In the over 85s, we're going to have a massive increase. So, over the next 20 years, the number of people living beyond age 80 will probably double. There's about 10 million. I think, according to the Office of National Statistics. Now, at the moment, that age group are about half of that age group are carrying at least 2 diagnoses, chronic diagnoses, cancer, cardiovascular disease, dementia, and so on. And we have very little evidence base to sort of base the management of that comorbidity. So I guess if there's a single point I would like to make as a researcher, it's that we need to focus a lot of our research in the future on these interactions between these coincident diseases in old people.
We need to be thinking R&D 5 years from now, but actually the regulatory framework doesn't exist at the moment. So there is a big challenge as far as resolving the regulations, but also there's a lot of work doing standardisation, standardising how technologies communicate with each other. It's often done at a very engineering level rather than at a data level. How is the information encoded? How is the security provided? What information is provided? That all needs to be worked out. I think it's going to get there, but I'm just a little bit concerned. If you look back 10 years, 15 years, the idea of the smart home, that was presented, that's going to come around the corner, but it still hasn't become mainstream yet. And I think there are a lot of significant technical hurdles still to overcome before we get to this sort of joined-up internet of healthcare, perhaps.
Anything you want to add?
Well, really, just to expand on that theme, really, I think there are two points to pick up. The first is that the quality of data that you can use depends on the quality of the information you can gather, and so it's incremental, but the technology of the Fitbit has to change before you can use data in a meaningful way to inform cardiovascular disease. I guess the second point is relates to your point about joining up information. And again, all the biometric information is really only valuable when it's linked to clinical data. And so then you run into enormous problems with no longer having an anonymized data set to work with. And I think that's one of the biggest barriers to progress at the moment. That working with anonymized data sets are fine to a point, but to really make this leap forwards, it needs to be linked to real clinical records.
Could I just add a follow-on from that? Because obviously if you take the personalised data that would come from widespread use of technology, and you add it to the genomic gene sequencing issue, I gather if you gene sequenced every person in the United States once, it will give you about 3 times 10 to the 20 bytes of data. So we're talking about very large amounts of data that you're trying to get access to. Do you think we have a clarity of how we will be able to access and properly use that data?
Well, clearly not at the moment, but I think that press release from Microsoft yesterday was extraordinary about what they plan to do with machine learning and artificial intelligence. And that analysis of genomic sequences really lends itself to that. There's a fascinating couple of books out there,
yes.
The genomic sequence, I think, just page after page of tiny script sequences of the gene pairs. And it's extraordinary, the amount of data that there is there, and how if one of those little pairs goes wrong, you've got a catastrophic health problem on your hands. So it really lends itself to that sort of very high-tech data analysis, which is automated and which has the potential for machine learning to make that stuff happen without employing millions of people to do it. So I think it's huge potential, but it's going to take the likes, as I said before, people like Bill Gates to do it.
Okay.
So I'm just going to pick up on that, because that's really interesting. It's an area that I do a little bit of work with myself. So we work with Microsoft on a sort of complex biological system. And it's true that you can employ machine learning technologies to find ever better correlations with very ever increasingly large data sets. What's always missing is a mechanistic link between the input and the output, and so there's a natural limit to what you'll be able to do with these correlative models of correlative models of large data sets, and what we need to strive for, and Microsoft would agree with this, are mechanism-based models. That's a whole new world, and that's very, very complex, and that's something that currently is difficult to imagine.
But this process that's in mind now is the foundation, presumably, for that to develop from that platform.
Yeah, I think that's absolutely right. It will happen at some point.
So
It's just a slightly different horizon. Yeah.
Any other question? Over there, sorry. Sorry, the light is just...
I'm David Barrett, I'm an orthopaedic surgeon. So my question is about how we enable the technology. So we've got a series of people on the podium who've got great ideas and are linking together. But the focus on us in healthcare, and I guess in industry, is cost containment. And so every time we go with a new idea to enable something or to make something better, if it costs more even to develop, it's all about reducing costs. And I just wondered, maybe each of the panel had an idea about how we had a financial model that allowed us to spend money to save money, because at the moment that's not really in healthcare, they just want to save money.
So it's about
I mean,
essentially the model for getting the justification?
Correct.
Or prioritisation?
No, I think it's more about how, because most of healthcare and I guess industry is about cost containment and cost reduction. A lot of these ideas will come at a cost, but will produce savings or better quality down the line. And so how do we enable that technology? Because at the moment there won't be a great enthusiasm for adopting it if it costs more in the short term.
Okay, it's a great question. I think it is a huge challenge. There's some examples of ways forward. So at a national level, AHSNs work collectively on something called the National Innovation Accelerator, which currently has 17 largely clinical entrepreneurs with ideas, projects that have been taken forward. They get mentoring, they get support. And actually two are local WAHSN based. One is My Own Health, which is digital support for respiratory disease, and another is scissors, which is scissors which reduce serious incidence damage to women during childbirth and so on. Simon Stevens at the Confederation conference in the summer announced innovation tariffs around some of these new technologies. So there is a recognition that the current business models around how trusts, primary care, you name it, any part of the health system gets paid is not aligned with the incentivisation of innovation. So there are moves afoot there which I think are helpful. The second thing I would say is a lot of the dysfunction is a consequence of actually fragmentation in the health system. So you can make an investment in acute care that saves money in primary care, but the institution logic is so perverse that actually the system doesn't pick up on that. I know there's quite a bit of scepticism about sustainability and transformation plans, STPs, but which is where you get, for example, University of Southampton working with clinical commissioning groups, working with the Mental Health Trust, but the idea is to take a systems perspective on what works for the population we serve. I think that puts a different set of incentives in the system, so you can start to say, if this works for the system and for our population, but it needs investment here in order to save money somewhere else in the system, that's a good thing. So I'm kind of hopeful in those two areas.
David, would you like to say anything in terms of how it works in industry and whether that's relevant from your viewpoint on the NHS?
Well, it's inevitable consequences. As technology gets more advanced, it becomes more expensive. And there is some changes, particularly on the very advanced exoskeletal robots, which are used for things like spinal cord injury patients, where these technologies are actually leased rather than bought outright. And I can imagine that as technology becomes more advanced and more costly, that model might be become more widespread. I think the other challenge that certainly our industry have in physical medicine rehabilitation is providing the cost-based evidence. I was at Cochrane a couple of days ago, and double-blind randomised clinical trial is the standard model that's sort of applied. And there was widespread recognition in the room that actually doing systematic study of evidence based on these principles doesn't necessarily work in rural and rehabilitation. So there is challenges, first of all, providing that initial justification, but also I think more consumer-oriented models will come out, like leasing cars now, for example, is very popular. That sort of model might be applied more widespread.
And adding from a sort of trust management point of view, one of the things that has changed is because of the tightness of money, there is, previously up until now, the NHS has controlled capital expenditure quite significantly, even though people talk about trusts, foundation trusts being independent. The ability to raise money outside of the standard government capital hasn't really been there, whereas now there is a recognition that perhaps alternative financing models, whether that's for capital or for undertaking research, there's starting to be an understanding that perhaps one would have to look at alternative mechanisms, and that, I think, will be quite helpful, because at the moment things tend to be very stovepiped. And consequently, when you're dealing with innovation and entrepreneurial systems, they often don't fit nicely into the model. And so I do think it is a time of change. Bill talked about the system-wide planning, but I also think that there are changes coming in the way in which one can deal with financing, which will give more freedom to trusts. But unfortunately, with the growth in older population and with higher and higher comorbidities creating demands for greater and greater complexity in the sort of treatment required, you've got to constantly balance this, if you like, how much money is available overall. Anything you want to add on that, Kieran?
Yeah, I was just going to say, I think we can't look at this in isolation of against what's happening with the health service at the moment and the trajectory of the health service. It is inevitable, it seems to me, that the NHS will be a commissioner of services and will provide less and less provision of services. It will be doing life and limb-threatening problems, acute medicine, psychiatry, paediatrics, and obstetrics. Everything else is going to get hived off. And we don't have at the moment the language, comes back to the data analysis, but we don't have the language or the framework to bring the private sector in to help us develop what you're saying, which is getting innovation in now, but sharing that risk and the cost with the private sector. I think that's going to be the way forward. It's interesting that Spire is sponsoring some of this event today, and that's going to be the way forward, is bringing in private providers who can spread the risk and share the investment in new technology to the benefit of all of us. But it's banging those heads together and overcoming the political obstacles of that, which will be a big challenge, I think.
Do you see anything in cancer, Tim, in the area of cancer, where more cooperation with the private sector?
Well,
I'd
like to reinforce the systems level sort of thinking around not only financial planning, but also governance. What are the barriers to being able to use large data sets that are being generated? As we speak, we've got 100,000 genomes in the Expo Hall. Is that the governance around those data sets is based in the trust. Individual trusts don't have the level of communication that's really required to interrogate those data sets before. And that probably will only get worse without some systems level thinking. I think it's embedded in 100 genomes, and of course, cancer is one of the diseases that project is targeting. So maybe we'll see some breakthroughs in the cancer genome before we see it in normal genomes.
Any other questions? I think then in that case I'll just ask one. I mean, we talked about the genome project. I think it would be much better to hear specifically where you think the genomic information is actually going to make the biggest difference when we look 20 years, putting you a bit on the spot, rather than it just being general use everywhere else. So, who's going to go first?
I'll kick off then. So, I mean, it's a really good question. The Human Genome Project has promised a lot for the past 25 years. And we haven't really seen much of that, those promises materialise. We have, however, seen an incredible increase in our understanding of disease etiology. We've seen new therapies arise as a result of the Human Genome Project. There's a great example in cancer in which a small proportion of a lung cancer carries a particular gene mutation that wasn't known about before that can be targeted with an existing drug that targets, that's been used in breast cancer. That was repurposed, and now those small slice of people enjoy a quality of life that was just unimaginable 10, 15 years ago. And there are many more examples like that. And I think it's really contributing, the genomic knowledge is contributing an enormous amount to the understanding of disease mechanism, and that will eventually lead to new therapies. That's slightly different, I think, to the question that you were specifically asking, which gets down to the challenge that the guys on the 100,000 Genomes Project posed when I visited their stand, which is, would you have your genome, or should everyone
have their genome
later on
in the workshop at 3:30.
And that is, for me, a different question entirely, because I think that the focus for answering that question needs to be on the societal evolution rather than technological evolution. I think we're already in a situation now where we as a species don't really know how we're going to handle information like that, and you just need to sit in a genetics clinic where the doctor talks to the family to sort of see the future. That actually the information that's being imparted between the physician and the proband, the other patient, actually belongs to the whole family. And take that one step further, actually belongs to the whole population from which that family is part of. And so I think we need some kind of societal evolution. We need to open up a debate that really isn't there at the moment before we can even start to answer your question, David.
Well, I think we've actually run out of time. Unless there's a very quick question someone wants to put in at the very end, I'd like to thank all four of our panellists for giving us a good insight into the future and explaining a little bit about where they see some of the challenges and difficulties that we will face. And I hope you join me in showing our appreciation for their efforts. Thank you very much.